Hello, welcome back to the Theoretical Revolution. My name is Mark Hatfull. This is video 2, the universe. The Theoretical Revolution is a video tutorial series trying to explain methodically my unified theory. This is the second video where I will briefly describe some of the phenomena of the universe, including how it was created. So, this is video number 2. Please watch video number 1 first. In my previous video I discussed a basic concept between the balance of two forces, the inward force of gravity and the outward force of a pressure gradient or a vacuum. If you have not seen the video 1, please watch video 1 first. This won't make much sense to you if you're just going straight to video 2. Alright, the universe. So, scientists believe that the universe is expanding because of dark energy. No one knows what dark energy is, or where it is, or how it works, but it is currently the only explanation for an expanding universe, unless of course you consider the Big Bang theory, which is again a theory that the universe is expanding because it is, and with no physical or no theoretical idea of why. So, apart from the Big Bang theory, which also does not explain why the universe is expanding. But I believe I can explain the creation of the universe and its expansion using simple and basic proven physics. So, let's say we have a container. Here's our container. We then put some particles in our container. Here we have some particles. These are individual particles in their most basic form. They have no additional energy in any way and are motionless. They only have the energy of their mass. There is no positive or negative pressure, and there is no positive pressure gradients inside or outside the container. There is only individual motionless particles distributed evenly through empty space. The only force on these particles is the force of gravity, and the force of gravity over time causes these particles to move together. Therefore, if the only force acting on these particles is gravity, the particles will be pulled inwards towards the center of the container due to gravity over time. Eventually, all the particles of mass will combine due to gravity in the center of the container. So, all our particles have now moved to the center of the container due to gravity. We now have a central mass of particles surrounded by empty space. But a number of things have happened. We have created new energy through movement, we've created kinetic energy, we've also created thermal energy. We've also created a pressure gradient between the positive force of particles and the surrounding relative negative pressure of the surrounding vacuum. Our previous neutral container now has an uneven distribution of mass surrounded by empty space. The central mass has a relative positive pressure due to all the particles, and the surrounding empty space has a relative negative pressure, or a vacuum. If the outwards force of the pressure gradient becomes greater than the inwards force of gravity, then the particles will redistribute outwards and our mass will expand. Therefore, the movement and distribution of particles is dependent on the balance between the inward force of gravity and the outward pressure gradient of a surrounding vacuum. So how does this relate to the creation of the universe? We can use this example to conceptualize the creation and expansion of the universe. Prior to the creation of the universe, there could have been any number of infinite scenarios for what may have been. But all we need for the creation of the universe is mass and empty space. So, here we have individual particles of mass, evenly distributed or relatively evenly distributed through empty space. Regardless of the size, movement, distribution of that mass, all mass would have eventually been drawn together in a single location due to gravity. So eventually, if we start with this, whatever form that is in, whether the particles are moving, clumped together, swirling in circles, we will eventually end up with a single solitary mass. So the creation of the universe. I believe that the universe started as a single solitary mass due to the collection of particles over time due to gravity. This mass was not infinitely large, nor was it infinitely dense, and it did not have an infinitely small space. This was just a very, very large mass in a very, very large space, which happened to contain all the mass of our universe. I call this mass a universal black hole because it's a giant black hole that contains all the mass of the universe. A universal black hole, or a UBH. So, the universe would have started as a single dense mass that contained all the mass of our known universe. I call this mass the universal black hole, or UBH. As the UBH, or universal black hole, continues to grow over time due to the gravity, so too does the surrounding negative force, or negative pressure. The empty space outside the universe is therefore a true vacuum. This is because it has an immense negative pressure gradient pulling the universe apart. This vacuum is not space as we know it inside the universe. I'll talk about space later in my next video, but for now we can imagine that the vacuum outside our universe is very different to the space inside our universe, because this vacuum outside our universe has an immense negative pressure. Therefore, to avoid confusion, I call the vacuum outside our universe negative space, because it is a space with a negative pressure. This is different to space, which is the space inside our universe, which I'll talk about later. So, if we have a giant mass, or a universal black hole, then the force of gravity is strongest in the centre of that mass. As we move outwards away from that mass, the force of gravity decreases, and the further away from that mass we move, the less the force of gravity becomes. Outside of this mass is an immense vacuum, or a negative space. This force of this negative space is strongest outside of the mass, and as we move in towards the centre of the mass, the further away from the vacuum we are, the less the force of the vacuum. And here this is represented by these arrows here. So, just to summarise what we talked about in the first video, if we have individual motionless particles evenly distributed through space, then each particle has 1 unit of gravity. If the particles are evenly distributed, then there is no pressure gradient and there is no negative force or vacuum in the empty space, which is represented here. If one particle of mass moves to join with another particle of mass, then that mass now has the gravitational force of 2 particles of mass. The gravitational force grows linearly for each individual mass. This mass still has 1 unit of gravity. If there was 3 particles, it would have 3 units of gravity. Once you move one particle towards another, you're left with an empty space. This empty space now contains a negative pressure, or a pressure gradient. This pressure gradient is then evenly distributed throughout the entire remaining vacuum or empty space. So only 1 unit of negative pressure is evenly distributed throughout the entire vacuum. As all the particles move or are redistributed towards the centre, they join to form a single solitary mass. This single solitary mass now has a gravitational force of 100 particles, as represented here. However, the surrounding vacuum has also increased. This has increased exponentially, and now the surrounding vacuum is catching up to the force of the single solitary mass. So if we look at that in graph form, as the number of particles in a mass increases, so too does the gravitational force of that mass in a linear distribution. As the surrounding vacuum is redistributed, so the particles are redistributed and the pressure distribution increases, the collective surrounding vacuum increases exponentially. If we combine those two graphs, then initially the force of gravity is the dominant force, and all the mass contracts towards the centre due to gravity. As that mass contracts, so too does the distribution of particles is also affected, and a surrounding vacuum is created. This vacuum is initially very weak, but exponentially grows as more particles are redistributed, and eventually this force of the surrounding vacuum will increase past the force of gravity for the individual mass. At this point, the force of the vacuum will now be the dominant force, and that will pull the mass outwards to create an expanding mass. So the universe. How does this relate to the universe? Well, initially the pressure gradient would have been very weak, and the gravity would have been the dominant force pulling mass inwards. As the pressure gradient increases, it will eventually reach or become greater than the inwards force of gravity. Once the threshold is reached, the contracting universal black hole containing all the mass of the universe will then be pulled apart rapidly due to the force of the surrounding vacuum being greater than the force of the inward force of gravity. Therefore, we can think of the universe as a giant expanding mass which is expanding into a surrounding vacuum of negative pressure, or a pressure gradient. This can be compared to a scuba diver's tank. A scuba diver's tank is full of compressed air, which contains a large mass of air in a small volume under a high pressure gradient. The pressure gradient is much higher than the surrounding atmosphere, which has a relative negative pressure compared to the pressure inside the tank. If the tank is open, then the air inside the tank rapidly expands outwards as it tries to equalize with the atmospheric pressure, despite the weak force of gravity trying to pull the particles inwards. This then explains the creation and expansion of the universe due to a combination of forces, the force of gravity versus the pressure gradient of negative space. The universe expands outwards in every direction like an expanding gas. So the balance of forces. The distribution of forces also changes depending on the location of particles in the mass. The inner mass has the greatest inward force of gravity and the least outward force of the negative space, and moves very little, if at all. The outer mass has the greatest pressure gradient from the surrounding vacuum and a smaller force of gravity, and therefore moves outwards the fastest. So the movement of mass distributed through the universe is dependent on the balance of forces for that individual mass, between the force of gravity inwards and the force of the pressure gradient outwards. So here we have our giant mass or universal black hole. This force of gravity is strongest in the centre, the force of negative space is weakest in the centre, so that the centre of the mass moves very little, or if at all, or continues to contract. The outer mass has the greatest force of negative space and the least force of gravity. Therefore, the outer layer of mass expands most rapidly. As the mass moves, the pressure gradient balance and distribution between the two forces also changes. So the further out the mass is from the centre, the weaker the force of gravity and the greater the force of negative space. So the outer mass may expand outwards at an accelerated rate, while the inner mass may contract inwards at an accelerated rate, depending on the distribution between the two forces. Cool. Alright, hope you're still with me there. This is just some graphs to demonstrate that. So here we have the force of gravity. As we move away from the mass, the force of gravity goes from 100%. The further away from the mass you are, the weaker the force of gravity. The opposite is true of negative space or the surrounding vacuum. So here, when you're outside the mass, the force of the negative space or vacuum is strongest at 100%, and as you move inwards away from the vacuum, the force of the vacuum decreases. When we combine those two forces, the force of gravity versus the force of the negative space. We then have the net force, or the net acting force, acting on mass. So in the centre, the force of gravity is the strongest, the force of the vacuum is the weakest. So the net force in this example is mostly inwards due to the force of gravity. All mass up to this point will be contracting inwards. Once we reach an equilibrium where the force of gravity equals the force of the surrounding vacuum, we have a net neutral force, and at this point, for a moment in time, the particles of mass will not be expanding or contracting. Any particles of mass outside this point, the force of the surrounding vacuum will be greater, and the force of the gravity will be weaker, and the dominant force will be the outward force of the surrounding vacuum. Here, the particles of mass will accelerate outwards away from the centre of the mass. So let's compare this theory to the current theory. Current theory. Currently we believe the universe is flat, right? According to NASA scientists, quote, "We now know that the universe is flat with only a 0.4% margin of error." We believe this because the universe appears homogeneous or homogeneous in every observable direction, right? In other words, we have found no curvature to the universe. Make sense? Well, it doesn't make sense to me. Just because the universe is almost exactly the same in every direction does not mean the universe is flat. It means that the universe does not appear to curve. There's quite a big difference between those two statements. In fact, we can see 13 billion light years in every direction, and the universe still appears homogeneous in every direction. We have not found an edge to the universe. So how can something that is at least 26 billion light years thick in every direction be flat? Here's a very basic diagram. This is, let's say, this is our universe. Here's us. For argument's sake, we're in the centre of the universe. I highly doubt that's true, but it just illustrates the point. If we look 13 billion light years in one direction, we can't see the edge of the universe. It looks the same in every direction. If we look 13 billion light years in every other direction, we still can't see the edge of the universe, and the universe is still homogeneous in every direction. So how can something that's 26 billion light years across, if we were in the centre of the universe and we could see all the way up to the edge of the universe in every direction, be flat? Nothing that I know of that's 26 billion light years thick is by definition flat. So let's look at something else. Let's say that this wasn't the universe. Let's say that this was my swimming pool, and this is me in the middle of my swimming pool. And if I look underwater in my swimming pool in this direction, and this direction, and this direction, I could say that my swimming pool appears homogeneous in every direction. That's because my swimming pool is full of water. Is the water in my swimming pool flat? Or the surface is flat, but the swimming pool itself, or the water in the swimming pool, isn't flat. It's evenly distributed throughout. The same if I was standing on top of a mountain. If I was looking at the atmosphere in every direction, I would say that the atmosphere appears to be homogeneous in every direction, provided I looked at the same pressure gradient and wasn't looking up or down in altitude due to, for argument's sake. So do we say that our atmosphere is flat? No. We say that our atmosphere is homogeneous, or the particles in our atmosphere are evenly distributed due to the forces acting on our atmosphere, which is the force of gravity. So, should we say our universe is flat? No. We should say that our universe is evenly distributed, that it is not flat, but that it is a three-dimensional distribution of mass. That is very different to being flat. So, I think of a piece of paper as being flat. I could understand how the world was thought to be flat because it looks flat. It's on a two-dimensional plane. If we see the horizon and we look above or below the horizon, we don't see the Earth, so it appears flat. But the universe doesn't even appear flat. It appears to be three-dimensional in every direction. Something that is flat is two-dimensional. If something is three-dimensional, then it is not flat. I'm sorry I'm labouring the point, but I believe firmly that the universe is not flat. The universe is an evenly distributed mass of particles, which I'll explain about more later. Therefore, the universe is three-dimensional and not flat. I believe that NASA scientists should have said that there is no curvature to the universe and that the universe appears homogeneous in every direction. This is completely different to being flat. The universe could be a perfect cube that is homogeneous in every direction and has no curvature, but that is definitely not flat. Okay, so I hope everyone's still following me and I haven't pissed anyone off yet, but this is just my ideas, and I'll move on to why this is relevant for unified theory. So, what is the shape of the universe? Let's forget about what we believe and look at what we know and observe. We know that we are surrounded by mass in every direction, so it is unlikely that the universe is flat. This mass appears to be evenly distributed or homogeneous in every direction, and we also know that the universe is expanding. We know that the universe is expanding because of the red shift, and we also know that every object that we see is moving away from us, and that the further away every object is, the faster it's moving away from us. Alright, so that's what I've just said. So, let's look at this in a diagram, try and simplify it a bit. Here we have us. This is our Earth, our solar system, our galaxy, whatever you want. This is a point in the universe. Alright, so it's very unlikely that we are the centre of the universe. So for argument's sake, let's say we're not the centre of the universe. Let's say if the universe is expanding, then we must be moving. So here we are. This is us. We're moving in a direction. Now we're moving towards something because we're surrounded by mass. So if we are moving towards something, why is everything moving away from us? Well, if the object we're moving towards is moving away from us, then the object must be moving away from us faster than we are moving towards it. But what about the object we're moving towards? What about it? Must be moving away towards something else as well. But this is moving away from us even faster, so it must be heading in the same direction. And so on and so forth. So every object we're moving towards is moving away from us faster, and every object that's moving towards is moving away faster than the object before that. So every object must be moving in the same direction, and every object must be moving faster than the object before it. What about the objects we're moving away from? Well, it's unlikely that that's the centre of the universe as well, so it's probably moving in the same direction as us, but it's probably not moving as fast. And the same for the object in front of that. But what about the objects on either side of us? We can only be moving in one direction, so what about the objects on either side? Well, they're also moving away from us. So, if those objects are moving, and they're moving away from us, then they must be heading on their own plane. Now we start to get a pattern which looks a little bit like this. Here we're moving away from every object that's around us, and the further away each object is, the faster it's moving away. If we can continue this pattern, we start to get a shape. So, what is that shape? If we extrapolate this information and we come up with a picture of or a photo, a freeze frame of the movement of our universe at a set point in time. What does that movement look like? It looks like this. Here we have an object which is moving. Every object around it is moving away from it, and the further away each object is, the faster it is moving away from it. If we extrapolate this shape, we can see that there must be a central mass which all objects are moving away from. The further away from the central mass that object is, the faster it must be moving away. Therefore, this picture right here is the first true and accurate picture of the universe as observed by all observable phenomenon. Alright, so take a look at this picture. Let's come back to that later. This gives us a lot of information about the universe. If the universe is evenly distributed throughout, and all objects in the universe are moving away from each other, then by definition the universe must have a center. All objects must be moving outwards from a central point in order for all objects to be moving away from each other. The universe must not be flat, because if it was flat, then we would not be expanding in every direction, but only in 2 dimensions. If the universe was flat, then the objects above and below us would not be moving away from us as the universe expanded or increased in thickness. Okay. If the universe has a central point in which it is expanding from, then the universe by definition must be finite, and I'll explain this more shortly. The universe cannot be expanding if there is nowhere for it to expand into. So if the universe is already infinitely big, then it is not possible for an infinitely big mass to increase in size, and therefore it is not possible for an infinitely big universe to expand any further. So this is a little bit difficult to explain, to conceptualize in your mind, so let's get some diagrams to make sense of this. So for simplicity's sake, let's say that the universe was infinitely large. Then we could imagine the universe in boxes. So if the universe is infinite, there would be an infinite number of boxes. If this small bit of universe that was inside one of our boxes expanded, then it could only expand to the size of the box. Once it expanded to the size of the box, it couldn't expand outside the box because that box is surrounded by other boxes, and therefore those boxes can't expand. The mass inside that universe, inside that box, can't expand. So the universe could not expand outside the box, and the box could not expand because the box is surrounded by infinite other boxes. Therefore, if we have an infinitely big universe, the universe cannot expand any larger because it is already infinitely big. So, therefore, if the universe is expanding, then by definition the universe is not infinite and must have an expanding border and a center to expand outwards from. Okay, so this is just a diagram to make sense of it. Here's a little part of the universe. It doesn't matter what part it is. It can be a small part, a big part. Inside that universe is a mass. We know that the mass of the universe is expanding. So outside of that part is other parts of the universe, and they're also in their boxes. So if our part of the universe starts expanding outwards, it expands outwards to the point where it reaches the edges of the box. Once it reaches the edges of the box, it can't expand anymore because the part of the universe above, below, and to the sides is also expanded to its maximum point. So if you have infinite boxes in every direction, the boxes can't expand, the mass inside the boxes can't expand, so even an infinite mass cannot expand. While I'm on this point, just a quick side topic, the same is true for a vacuum. Some of you may think, well, how can an infinitely big space have a pressure gradient or a vacuum? It's the exact same concept. If you've got evenly distributed particles, if those particles combine down into a single space, then you're creating a vacuum in that side. You're also creating a vacuum in all the other boxes. If you've got infinite boxes in every direction, then an infinitely large space can theoretically still have a negative pressure or a negative vacuum. Anyway, moving on. The size and shape of the universe. Therefore, we know that because the universe is expanding, that the universe is not infinite. It must have a finite mass. There must be a center for that mass to expand from, and there must be a border in which that mass is expanding into. And finally, If the mass is expanding in every direction, then that mass cannot, by definition, be flat. Therefore, the shape of the universe can be thought of as a giant expanding mass. This is similar to a gas expanding from a scuba tank or an expanding cloud. So, using the above information, I have come up with a model of the universe that demonstrates the movements of the universe over time. This concept is extremely simple and works on a number of presumptions, all of which I've already discussed in the previous two videos. So firstly, the universe is expanding outwards from a central point in every direction. Secondly, that there are two forces acting on the universe. There is a force of gravity pulling mass inwards. There is a force of a pressure gradient or vacuum outside the universe pulling the universe outwards. The outwards force from the universe causing it to expand. Therefore, the mass of the universe has the inward force of gravity and the outwards expanding force from the negative pressure or vacuum. The distribution of these forces changes depending on the location of mass in the universe and changes on each mass over time. If we were to artificially divide the mass of the universe into rings, then depending on the mass's location of the universe, we can determine the net force acting on that mass at any one time. The change in movement of that ring is dependent on the net sum of the forces on that ring at any one time. Alright, so sorry I'm getting a bit complicated here, let's try and simplify it down. No, I don't have a diagram yet, give me a second. So, in the innermost mass, the innermost mass has the greatest inward force and the least outward force. That's because the innermost mass has the greatest force of gravity and is furthest away from the vacuum. Therefore, the innermost mass is likely still contracting or has the least expansion. As each consecutive layer or ring of mass that you move outwards through the mass of the universe, the force of gravity becomes less and the force of the vacuum becomes stronger. The net movement of that ring of mass is then dependent on the net force of between the force of gravity and the force of the vacuum. As you move outward each individual ring, that ring will then expand outwards faster than the ring before it. The very outermost mass has the least inward force from gravity and the greatest outwards force, and therefore moves outwards the fastest. This is represented in the ring model, which I'll come to shortly. So here's just what I was saying. Here you have a giant mass, a central universal black hole containing all the mass of the universe. Inside the center of the mass is the greatest force of gravity. The further away from that mass you move, the smaller the force or the less the force of gravity becomes. Outside that mass is a giant vacuum of negative pressure. This pressure is strongest outside the vacuum, and as you move towards the center, becomes weaker. Here's our picture of the universe. So, as I said before, you can imagine the universe in rings. Here we have each individual ring of the universe. So, in the center of the universe, or this innermost ring of the universe, the mass is most dense, the force of gravity is the strongest, and the force of the surrounding vacuum outside the universe is the weakest. So this innermost mass moves very little. As you move to the next layer out, the second ring, you can see that the force of gravity is slightly less and the force of the vacuum is slightly more. So this ring of mass is moving outwards faster than the inner ring of mass, but slower than the mass outside that. And this is replicated in each consecutive ring as each ring of mass moves away from the center faster than the ring before it, all the way to the outside, where the outermost mass has the greatest outward force due to the vacuum and the least inward force due to gravity, and therefore is accelerating away the fastest. If you go back to our observed phenomena of the universe, you can see that any individual point, all mass surrounding that point is moving away from that mass as it moves outwards, and the further away you are from any individual mass, the faster it's moving away. Therefore, this model of the universe demonstrates all observed phenomena of the universe, that the universe is expanding, that why the universe is expanding, that all mass is moving outwards from all other mass, and the faster way it is moving, further away it is, the faster way it's moving. You can then extrapolate this picture of the universe to get a picture of time. So, going back, we've seen this graph before. The force of gravity decreases the further away from the mass you get. The force of the vacuum decreases the closer in towards the mass you get. And the net force is the difference between the two forces. If the force of gravity is greater, then the net movement will be inwards due to gravity. If the net force of the vacuum is greater, then the net movement will be outwards and the mass will expand. Alright, this is the ring model. So, if we take the presumption that all the mass of the universe initiated in a single location, the universal black hole, then if we take each individual ring and we graph its movement over time, we end up with a picture like this. So here we have the inner ring at point 0, and over time the ring moves slightly outwards but decelerates due to the force of gravity to the point of stopping, and then due to the force of gravity then accelerates back towards the center of the universe. Each consecutive ring moves a little bit further and a little bit faster than the ring before it. So here, the next ring out from the center of the universe moves further and faster because there's less force of gravity and greater force of vacuum, but also decelerates and then eventually accelerates back due to gravity over time. This is replicated in each consecutive ring so that each outer ring then accelerates away faster, takes longer to decelerate, and then accelerates back to the center, and so on and so forth. Now you can divide the universe into as many hypothetical rings as you want. This is just a diagram to illustrate the point that here I've done 5 rings, but you can do 2 rings or 2 million rings. Anyway, what does that look like in a picture? Well, here we have time 0. So time 0 is here. All the mass of the universe is in a central location. Here I've divided the universe into 3 rings: inner, middle, and outer rings. All the mass of the universe is at point 0 here. Now, when the universe expands, or the force of negative space becomes greater than the force of gravity, the universe will expand outwards rapidly. The outer ring will expand the fastest because the force of the vacuum will be strongest on the outer ring and the force of gravity will be least. So, when we move to time 1, the universe here has expanded. The outer ring has expanded 3 units of distance over 1 unit of time. The inner ring has only expanded 1, and each consecutive ring has expanded 1 unit of distance per unit of time faster than the ring before it. As we continue to time 2, then the force of gravity will cause the deceleration of these expanding rings, and now the universe is still expanding, but the outer ring, so let's start with the middle ring. The middle ring hasn't moved away, it's still at point 1 because it has decelerated due to the force of gravity, and next unit of time will actually decelerate or accelerate back towards the center. The second ring here is still expanding and accelerating away, but it's beginning to decelerate due to the force of gravity. And here you have it here. It went from 2 rings and then in the first unit of time, and then only moved 1 unit the second unit of time. And here we have the third ring, and that's decelerating as well, but still expanding outwards. If we look at this now, the inner ring has accelerated back towards the center and is where it began initially. The second ring has now stopped moving and decelerated, and the balance of forces between gravity and the outward vacuum are now even, and that ring stops moving, whereas the outer ring is still expanding outwards. So here in this 1 unit of time, we have a single universe, but we have a contracting inner ring because the force of gravity is greater than the force of the surrounding vacuum. We have a motionless second ring because the force of the vacuum equals the force of the surrounding gravity. And then we have an expanding outer ring because the force of the vacuum is greater than the force of the inward force of gravity. So simultaneously we can have a universe which is contracting, motionless, and expanding all at the same time. Therefore, our universe may not in fact be expanding, but just the part of the universe that we are in is expanding at an accelerated rate. The rest of the universe may actually be contracting or motionless. Here's unit 4 of time, so here we've got 4, the innermost ring has remained at the centre, the force of gravity is the dominant force, there's no force of vacuum pulling it outwards. The middle ring is now accelerating back towards the centre due to gravity, and the third ring has now become motionless as the force of gravity and the force of the vacuum have equaled each other. Now in this scenario I've made it so that the gravity is the dominant force and that all rings end up decelerating, stopping and returning to the centre of the universe due to the force of gravity. However, in reality, this may not be the case. We may get, the further away a ring gets, the vacuum may be the dominant force, and they may actually begin to accelerate outwards again and never return to the centre. So now we continue, the rings begin to move back towards the centre, and we have the end of, or the hypothetical end of the universe. So if I go from the start to the finish, we have a single solitary mass with an outwards vacuum pulling it outwards, an inward force of gravity. It expands over time due to the outward force of the vacuum, and then eventually begins to contract back to the same point it started, ending up back at point 1 with a single solitary mass in the centre of the universe. We then have a timeline of our universe from beginning to end. However, as I said, if the force of the vacuum is stronger than the force of the gravity, then we may have a continually or infinitely expanding universe, and the universe may never contract. Alright, everyone take a breath. I hope you're following me so far. So it's a new concept, there's a lot to take in. I hope you're all kind of still on track with me at the moment. Let's see what we've got. So we've got the ring model. This is a diagram of the shape and distribution of mass in the universe over time. In the above diagram, I have broken down the mass of the universe into 3 rings. However, this model can use as many rings as necessary. In reality, would not use rings at all, but be a continuum or a spectrum from the inside of the universe to the outside of the universe as a continuum. The universe therefore begins in a central single mass. It expands outwards in every direction in hypothetical rings. The inner ring expands slowly, and each consecutive outer ring expands faster than the ring before it. Each ring decelerates to the point of stopping before accelerating back towards the centre, depending on the distribution between the inward force of gravity and the outward force of the surrounding vacuum. If the outward force of the surrounding vacuum is always greater than the force of gravity, then the universe or the outer rings may always expand or continue to accelerate outwards. Each outer ring then therefore takes longer to slow down than the previous ring before it, and due to the balance of forces between the inwards and outwards forces. The outer ring may in fact never stop or accelerate, as the force of the gravity decreases as the mass moves further from the centre of the universe. Alright, so just to go back to a quick point, this is not the Big Bang Theory. This is not that all the mass of the universe exploded outwards at a single point for an unknown cause. This is not an infinitely dense mass in an infinitely dense space in an infinitely small volume. This is an extremely large mass containing all the mass of the universe, but not an infinite mass, which is not infinitely dense, but may in fact be quite dense, and does not take an infinitely small volume, but in fact takes an extremely large volume, the volume of which is expanding all the time due to the outwards force of the negative pressure. So this is not the Big Bang Theory. This does follow all physics principles. And this can and is simply replicated as we see with any expanding mass, like the mass of gas in a scuba diver's tank. Anyway, where are we up to? Let's skip all this. Alright, the ring model therefore gives us an accurate shape and distribution of the movement of the universe over time from beginning to end. It is also consistent with all current observed phenomena. At any point in the universe is surrounded by mass in every direction. All the mass in the universe is moving away from all other surrounding mass, and the further away that mass is from any one point, the faster it is moving away. So this does agree with all observed phenomena. What this doesn't agree with is current theory that the universe is flat, that the universe started from a Big Bang. So using the ring model, we can now better understand the shape and movements of the universe. We can use the ring model to also look back and forward in time to help us predict the movements of the universe. Alright, so far so good. I hope I haven't lost too many of you. I hope you're still listening. I hope you're still interested. I hope I haven't upset anyone. So let's go to our checklist. We have a single concept. We have a concept that the universe is a mass, that outside the universe there is no mass, and that the movement of the universe moves depending on the distribution of the forces of gravity versus the forces of an outwards pressure gradient or vacuum. Okay? Simple. I hope that's simple. It's simple and it follows both basic proven science. We know osmotic gradients, we know pressure gradients, we know that a mass expands or a gas expands into an area of lower pressure. We know that mass moves inwards due to gravity. There are no complicated concepts. We haven't introduced strings, we haven't introduced alternative dimensions, I haven't introduced dark energy or dark matter. I have explained a simple concept that uses basic proven physics to explain why a mass like the mass of our universe would expand. This mass, so what phenomenon have I explained? Well, I've begun to explain the universe. I haven't answered every question in the universe, and there's a lot more to talk about. I will talk about it, and it's all in my book, but for now we've begun to understand a little bit more about the universe. What haven't we done? We haven't talked about gravity, we haven't talked about light, we haven't talked about time, dark energy, dark matter, or any of the other phenomena in the universe. So, in my next video, we are going to explain how the unified theory helps us to understand all observable phenomena. In particular, I'm going to discuss the composition of space and the composition of space-time. We're going to talk about light, dark energy, and dark matter. So, thank you very much for listening. You've now made it through 2 videos. I'm very appreciative of that. You're doing really well. Hang in there while I talk about space next. So please come to my 3rd video, video 3, space. And for more information, just read my book, which you can get a free copy on my website. I haven't posted it yet, but it'll be up there soon. You can get a free $3 Kindle book, or you can actually get a hardcover. It's only $10. It's the cheapest I can make it, but you can just get the free PDF on the website if you want it.